What if the very fabric of our reality, the fundamental building blocks of everything we perceive, isn't quite what it seems?
Right?
Imagine living in a system so profound, so mathematically intricate, that it might actually resemble a highly advanced, layered code.
Yeah, a bit like those iconic stories where what you experience isn't the whole picture.
Exactly. Think of something compelling like The Matrix, that
Yeah.
kind of layered reality.
Well, today we're embarking on a really fascinating deep dive. We're looking at sources that explore the nature of reality itself,
From the limits of human perception.
all the way to the cutting edge of theoretical physics. Yeah. Our mission, really, is to unpack these theories about higher dimensions, these kind of mind-bending geometric structures.
And even that audacious idea that our universe is fundamentally like a code.
Precisely. And all of this, it presents a really logical mesh with those kinds of layered realities we see in fiction.
So get ready to connect some surprising dots, because we're going to try and unravel some pretty complex ideas.
Make the core insights hopefully crystal clear for you.
Yeah, helping you see the universe in maybe a completely new light. Okay, so before we dive headfirst into the universe's secret code, maybe we should confront a fundamental barrier first,
Which is?
the limits of our own perception.
Yeah.
Because if our minds struggle with even, basic concepts, how can we hope to comprehend the truly mind-bending stuff?
That's a fair point, like infinity, for instance.
Right, infinity.
What's fascinating there is how our brains just intuitively resist concepts without a clear start or end.
Mm-hmm.
Imagine, like, you were born and just found yourself completely surrounded by water. No memory of a time before the water.
Okay.
If you asked, how did I get here? The only really honest answer would be, well, you've always been here.
It's kind of a false question then, isn't it? But when did I enter the pool?
Exactly. You never entered. You've always been in it.
But where was I before I was in the pool?
There's no before you weren't in the pool. That's the infinite. They always existed.
And our human minds, they're built for beginnings and ends. That just,
Yeah.
it doesn't compute easily.
No, it really doesn't. And that struggle, it extends to nothingness, too. Try picturing it.
Uh-huh. Darkness.
Most people go there, yeah. But darkness is a presence, isn't it? A state of being. Or they might think of empty space.
But empty space still has dimensions. It contains something, even if it's just potential.
Right. Our intuition really grapples with true absence.
Okay, so our minds might stumble here. But this is where maths comes in, right? It gives us a language for what our intuition can't quite grasp.
Precisely. We might not truly experience nothingness, but mathematically, it's defined.
Like set theory's empty set. Or just the number zero.
Exactly.
Hmm.
Math gives us a precise symbol for the complete absence of quantity. It handles it perfectly.
Okay. And the same for infinity.
Same idea. We can't really grasp its boundless nature, not intuitively, yet it can be robustly represented, manipulated in equations.
So mathematically, it's real. It
Mhm.
exists and it's foundational in physics and cosmology. And this kind of leads us to another concept our brains struggle with, even though mathematically it's, well, perfectly fine. Higher dimensions.
Ah, yes. Beyond the three we know.
How do we even start to conceptualize that?
Well, think about a simple 2D square, flat on a page, defined by an x and a y-axis.
Got it. Length and width.
Now add a z-axis, height, and it pops out into a three-dimensional cube.
Right. That's easy enough. We live in 3D.
But mathematically, what stops us adding another axis, a fourth one?
Nothing.
Exactly. You can extend a 3D cube mathematically to create a four-dimensional hypercube, a tesseract.
Even though we can't, see it with our eyes, our brains are wired for 3 spatial dimensions.
Correct. But these higher dimensions are perfectly describable, manipulable in mathematical terms.
And it doesn't stop at 4, does it?
Not at all. You can mathematically construct a 5D cube, a 6D cube. Theoretically, shapes in, well, endless dimensions.
So while we can't perceive them, maths provides the framework. It defines them, lets us explore them. Okay, so now we've established that higher dimensions are, mathematically at least, legit. Let's turn to something really specific and, frankly, astounding.
E8.
E8, this incredibly intricate 8-dimensional geometric structure, a lattice.
And what's truly fascinating, almost bonkers really, is that this profound 8-dimensional structure, E8, it appears to encode all the fundamental particles and forces.
All the stuff that makes up our familiar 3-dimensional reality, encoded in 8D geometry.
That's what the math suggests, a hidden order at the universe's deepest level.
Okay, so what is E8? Can we make it more tangible? You mentioned packing.
Right, let's use an analogy. Dentist packing. Imagine circles, all the same size, on a piece of paper. How do you fit the most in?
Like a honeycomb, hexagonal pattern.
Exactly, hexagonal packing. Now imagine putting a single point right in the center of each circle.
Okay.
Then just remove the circles. What you're left with is a very precise arrangement of points, a point space. And that pattern represents the densest way to pack 2D circles.
Right. Makes sense.
Now, let's go to 3 dimensions. Think about stacking oranges at the supermarket.
Yeah, that pyramid shape.
That's the densest packing for 3D spheres. And interestingly, the mathematical proof for that optimal packing only formally done in 2014.
Wow. Really? Even though people have stacked oranges forever.
Yep. So again, imagine putting a point at the center of each sphere and removing the oranges. You'd have a 3D point space, or lattice, representing the densest packing of 3D spheres.
Okay, I think I see where this is going. Following that logic, E8 is.
It's simply the point space, or lattice, that represents the densest possible packing of 8-dimensional spheres.
Whoa.
It takes that same concept of optimal arrangement and just leaps into 8 dimensions. Creates this incredibly complex but perfectly ordered structure.
Okay, so that leads us naturally to one of the biggest challenges in physics, right? Unification.
The big one. Unifying Einstein's general relativity gravity, space-time curvature on the large scale.
Like planets bending the fabric of space.
Right. Unifying that with quantum mechanics, the rules governing the incredibly small subatomic particles, forces.
And this unified theory is the theory of everything, or quantum gravity.
That's the goal. And for decades, string theory was really the main contender trying to do this.
You got a lot of attention, a lot of funding.
It did, but the critique, and you hear this from physicists like Garrett DC, whose work we're looking at, is that it hasn't produced successful testable predictions.
Right. Garrett DC apparently felt it overpromised and underdelivered, made unjustified assumptions, got ridiculously complicated.
Yeah, and he also pointed out the sort of inertia you get in academia, big grants, lots of PhDs based on a theory. It can keep research going even if it's not bearing empirical fruit.
So what did Garrett DC do differently?
Well, he took a path really rooted in Einstein's geometric description of gravity. He loved that geometric approach, so he thought maybe we need a matching geometric description for the elementary particles too. He believed the universe must have some kind of unified, elegant structure underneath.
And he found inspiration in mathematics itself.
Exactly. He found that fundamental mathematics often reveals these, beautiful structures that turn out to perfectly describe our physical universe. It's a recurring theme.
Okay, so let's talk about an older geometric idea that kind of sets the stage for Garrett's work. Fibers.
Right, the concept of fibers. Imagine, just for a moment, we lived in a totally flat, two-dimensional universe.
Flatland.
In that 2D world, a particle, say a photon, wouldn't just be a point moving on the flat plane. The idea is there's a little circle attached to it.
A circle. Where?
Existing in a higher third dimension, just above our 2D universe, so to speak.
Oh, okay. Hidden dimension.
Sort of. The particle itself is effectively just a point moving along this hidden circle. We only see its effect, its position, in our 2D space.
And this circle is called a fiber?
Exactly. And its subtle movements, twists, rotations in that higher dimension. That's what appears as the particle's behavior in our observable reality.
And different combinations of these fibers.
Form mathematical structures called Lie groups. And crucially, these aren't just abstract math. Each Lie group precisely corresponds to a specific fundamental particle or force.
Like the weak force having 3 twisting circles you mentioned.
That's the idea, yes.
And this isn't just a 2D thought experiment.
No, not at all. In our actual 3D universe, the concept holds. These fibers are attached to every single point in our space and time.
But they exist in even higher dimensions.
Correct. And as these fibers twist and turn through space and time, what we perceive, what we measure in our 3D world, are particles moving, forces interacting.
And you're saying this geometric description of matter and forces, it's standard physics for over 70 years.
It is. It's a well-established concept, this geometric underpinning using fibers and Lie groups.
Okay, so where does Garrett DC's breakthrough come in? How does E8 fit?
His breakthrough was a remarkable synthesis. He found that if you mathematically add together the Lie groups for everything,
Everything.
gravity, electromagnetism, the weak force, the strong force, all the known fundamental forces, plus the Lie groups for all the known particles, electrons, quarks, etc., and even theorized particles like the graviton.
Okay, add all those mathematical descriptions together.
They all coalesced. They formed one single massive unifying Lie group.
Let me guess.
That overarching structure, it's E8.
Wow, okay. That's
Yeah.
elegant.
It really is. And here's the compelling part. E8 is considered by many mathematicians to be perhaps the most beautiful structure in all of mathematics, just intrinsically, for its symmetry and properties.
So the most beautiful mathematical structure happens to map onto all the fundamental bits of reality.
The correspondence is striking. It's very promising. There are still details to work out, absolutely. But the fact that this abstractly beautiful thing seems to describe nature so well, that's significant.
Can we simplify that visually? Like, what does it mean for E8 to be behind everything?
Okay, try this. Imagine a complex, like an 8-dimensional E8 machine operating behind every single point, every particle in our 3D world.
A machine in 8D.
Yeah. And how we perceive a particle, whether we see it as an electron or a quark or a photon, isn't just some fixed property of the particle. It's more like an expression of what this E8 machine is doing in the 8th dimension. Its state, its orientation relative to us.
So an electron and a quark aren't fundamentally different things. They're just different activities of the same underlying E8 structure.
That's the implication. A profound geometric unity. All particles, all forces, maybe even space-time itself, they're not separate entities. They're just different perspectives, different twists or fibers of this single, elegant, 8-dimensional geometry.
It really paints a picture where the universe is, quite literally, a living piece of mathematics.
In a way, yes.
Okay, if the universe is a living piece of mathematics, that leads us perfectly to Clee Irwin, director of quantum gravity research, and his emergence theory.
Right. He posits that reality at its most fundamental level is essentially a code or a language.
And this code's deeply related to E8. This is where the matrix comparison really feels quite direct, doesn't it?
It does have that flavor. Klee's theory suggests the universe's ultimate building block, like its fundamental pixel, is 3-dimensional. It's the tetrahedron.
A 3D equilateral triangle, like a four-sided die.
Exactly. And these tetrahedra combine, following very precise mathematical rules, into this massive, intricate structure, a network.
And this network is derived from E8.
Directly derived from the E8 geometry, yes.
But hang on, that brings up the same issue again. If it's all based on 8D geometry, but we only experience 3D, how does that work? How do we reconcile that?
Their proposed solution involves something called quasicrystals.
Okay. What's a quasicrystal?
Well, first think of a regular crystal, like salt or a diamond. It has a perfectly repeating pattern, right? Like tiles on a floor or a 3D checkerboard lattice. Periodic.
Got it. Repeats perfectly.
A quasicrystal, though, is aperiodic. It has order, it's not random, but the pattern never perfectly repeats itself.
How do you get that?
Crucially, quasicrystals can be formed mathematically by projecting a crystal from a higher dimension down onto a lower one.
Like casting a shadow.
Exactly like casting a complex shadow. And remember, the E8 lattice we talked about.
The densest packing of 8D spheres.
It is an 8-dimensional crystal, a perfectly repeating pattern in 8D.
Okay. So Klee's group theorizes projecting this 8D E8 crystal.
Down to 4 dimensions and then down again to 3 dimensions. And they do this projection at a very specific, irrational angle. It's mathematically precise.
And the result of this projection, this 3D shadow.
This is the amazing part. The resulting 3D object isn't just a shape, it becomes a language.
A language, how?
It forms a finite set of geometric letters, basic shapes derived from the projection. There are strict rules about how these letters can connect, how they can be arranged.
Okay, rules like grammar.
Sort of. But within those rules, there's also freedom, degrees of freedom that allow this arrangement to encode information.
So this 3D quasicrystal, it's a geometric code.
Essentially, yes. A code composed of geometric symbols that express meaning, and the meaning it expresses is reality itself.
Wow. Okay, comparing that to the Matrix again. In the movie, the world Neo experiences is a simulation. It's code running, a projection of some higher-level system that defines all the rules, all the details.
Right.
And Klee's theory sounds similar, but instead of computer code, it's geometric code. And it avoids needing those extra dimensions to be hidden or curled up really small, like string theory sometimes suggests.
That seems to be the advantage they highlight. The lower dimensional quasicrystal itself, the 3D structure, inherently encodes all the information from the higher dimensional E8 mathematics.
So our observable reality is the rendered projection. It contains all the information of the underlying, more fundamental 8D system.
That's the picture they're painting, yes.
The implications are, huge.
Immense. If these theories, or something like them, are proven correct, if we discover the actual keys to the fabric of reality, understand this pixelated scale of existence,
It could unlock What a treasure trove of new technologies, new philosophies even.
Potentially. It would be like having the master key to the kingdom, understanding the fundamental code of existence.
Maybe even interacting with it. Like Neo learning to manipulate the Matrix code once he understands it.
That's the speculative, far-reaching possibility, yes.
Well, what a journey that was.
Wow.
Through some seriously complex, beautiful, and, utterly mysterious ideas about our universe.
It really is mind-stretching stuff.
And whether or not Cleo Irwin's emergence theory or Garrett Deasy's E8-based model ends up being the final theory of everything.
And they are still contenders, still being developed and debated.
Right. It does seem like many physicists increasingly believe reality is deeply tied to these higher dimensional objects, these elegant mathematical structures.
Absolutely. And E8, as real and as mysterious as it is, it certainly stands as a very compelling contender on that road to a theory of everything.
The whole pursuit is just fascinating, this quest for knowledge about reality itself.
It's a winding path, isn't it? Full of incredible leaps of insight, but also long periods of challenging uncertainty and hard work.
So let's leave our listeners with this. If our universe really is a kind of geometric code, maybe a living piece of mathematics, what does that imply?
What does it mean for consciousness, for free will, our place within this incredibly vast, elegant system?
Yeah. What new possibilities could emerge if we could truly understand that deep code of reality?
Something to ponder. What do you think?